Okay, we're going to talk about doing long division with polynomials. And the reason we want to do long division with polynomials is because we want to find all the zeros of polynomials to help us graph it. And zeros are often very important part of applications when we have polynomials. And this theorem is kind of what leads us to do it. It says, it's called the factor theorem, and it says if p of x is a non-zero polynomial, the real number c is a zero polynomial if and only if x minus c is a factor. So ideally what we want to do is we want to factor everything so that we can find all the zeros. Okay, now what we're going to do is if we think something's a factor, we can do long division. So here we're going to be dividing a polynomial p of x by another polynomial d of x. Okay, and what the polynomial division theorem says, it says suppose d of x and p of x are non-zero polynomials and the degree of p of x is greater than or equal to d of x. So what we're saying there is p of x just has to be a polynomial that has a higher degree or equal to what you're dividing into it. Then there exist two unique polynomials, q of x and r of x, such that you can write it this way. The polynomial you were dividing into equals what you were dividing into it times some quotient plus a remainder. Okay, so we have some terms here. So p of x, what we're dividing into is called the dividend. What we're dividing into it, d of x, is called the divisor. We'll do long division just like you did with numbers. We'll have a bar, and what you get up top, that's called our quotient. And then if you have a remainder, we call that r of x. Okay, now if the remainder is 0, then the divisor, what you were dividing into, is a factor of your polynomial, and that's what we're really looking for. Okay, so we're going to go ahead and do some polynomial long division. So we want to divide x cubed minus 9x squared plus 15x plus 25 by x minus 5. So we're going to set up this kind of division box like you would have with numbers. And we're going to put the terms in descending order. If you're missing any, you'd put in, so for example, if we didn't have an x squared term, we would put in 0x squared. And then we'll put our divisor here. Okay, now what we're always doing is we're saying, what is our first term here, x cubed divided by x. And x cubed divided by x, you're really just taking a power of x away, so that would give us x squared. Now we want to multiply that by each of our terms here. So we would do x squared times x will give us x cubed, and x squared times negative 5 would give us minus 5x squared. Now, what we do in long division is we subtract. Now, subtracting, here you have to be really careful about distributing the negative, and so we can actually turn it into addition if we change the signs. So the way you can remember this is that you're going to draw the line and change all the signs. So change it to addition and change the other two signs. Draw the line, change the signs. Now adding, the first term should always cancel each other out. X cubed plus negative x cubed is 0. Then we have minus 9x squared plus 5x squared, so that'll be minus 4x squared. And now we're going to bring terms down. So we'll have plus 15x plus 25. Okay, and now we kind of repeat the process over from the beginning. Oops, got rid of my divisor board there. We're going to say, okay, what is negative 4x squared divided by x? Well, it would be minus 4x. So now I'll distribute that. Negative 4x times x will give us negative 4x squared. And negative 4x times negative 5 will give us plus 20x. Okay, remember, draw the line. This should have been a minus. Change the sign. So change that to a plus, plus, minus. So these cancel out. 15x plus a negative 20x gives us minus 5x. And we'll bring down the 25. Okay, so now what is negative 5x divided by x? Well, that's negative 5. And when we distribute here, negative 5 times x will be negative 5x, and negative 5 times negative 5 will be plus 25. And we can see these are exactly the same, so when we subtract, we're going to get 0, and that's actually our remainder now. We don't have anything else to bring down. So what this means, if we want to write it as p of x equals d of x, q of x, plus r of x, we would have x cubed minus 9x squared plus 15x plus 25 equals x minus 5 times our quotient, which is up here, x squared minus 4x minus 5. Okay, now we don't have to write the plus 0 because adding 0 doesn't change anything. So what we did here is we just started to factor this cubic polynomial. Okay, so we did that division. Okay, now we want to do x cubed minus 8 divided by x plus 2. And I'll go ahead and erase some of this so we have kind of a clean workspace. Now, x cubed minus 8 doesn't have an x squared term or an x term, so we're going to write it as x cubed plus 0x squared plus 0x minus 8. And x plus 2. Okay, so we say what is x cubed divided by x? Well, that's x squared. So we'd have x cubed plus 2x squared. We're subtracting, but we draw the line, change the signs. So these cancel out. We have 0x squared plus a negative 2x squared, so that's minus 2x squared. 0x minus 8. So now I'd say what is negative 2x squared divided by x? Well, that'll be minus 2x. Now I'm going to distribute that. So negative 2x times x will give us minus 2x squared. Negative 2x times positive 2 will give us negative 4x. So we're subtracting, but we draw the line, change the signs. So these cancel out. Here we have a 0x plus a positive 4x, so we get 4x minus 8. Okay, so now we do, okay, what is 4x divided by x? Well, that would just be a positive 4. We distribute, so we get 4x plus 8. Draw the line, change the signs. So here we've got 4x minus 4x. We have negative 8 minus 8, so that'll give us a negative 16. And that will be our remainder. So this one doesn't divide unevenly, but what we can do is we can write this as x cubed minus 8, our p of x, and then our d of x, x plus 2, times our quotient, x squared minus 2x plus 4, plus our remainder, so minus 16. And that would be kind of our final answer of our division.